Thank you, and good afternoon, everyone. Thanks for joining us today. And please, Joshua Showalter, Marketing Director in the room, joined here today with Richard Lindsay, Director of Engineering, Jim Chamberlain, Engineering Group Manager, Design Services, and Andy Mulrooney, Technical Sales Manager. And to kick us off, I'll turn it over to Richard Lindsay.
Thanks, Josh. Good afternoon, everyone. We are excited and passionate about the topics we're going to be discussing today. First question we ask ourselves are you capacity constrained, looking to invest in new processes and equipment to improve capacity, or simply looking to reduce the amount of time that is spent cleaning? We are going to discuss the differentiated value that Ecolab can bring to you to help you in these areas. We're going to show you exactly what that process entails and the impact that it could have on your cleaning and sanitation program. We're going to follow that up with a discussion on CIP solutions we can offer and how that ties back into differentiated value. We will follow that up with a discussion on some of our facility cleaning solutions and one of our antimicrobial offerings. Finally, we will walk around our bulk chemical storage and distribution solution. Each one of these topics will be followed by examples and case studies on the impact these can have on you, your employees, your customers, and the world we live in. We believe that regardless if your business is food, beverage, or brew, you have these four main objectives. You must produce your product in a safe and efficient manner. Safety, both consumer and employee, is everyone's top priority, where any incidents are unacceptable. You must also produce your products in the most efficient way possible, reducing downtime at every opportunity. In today's marketplace, you must also produce your products at the lowest possible cost, thus maximizing your stakeholders' value. While maintaining your profitability, you must also produce your product in a responsible way, being a good steward for the environment. We share those objectives, and those are the pillars that drive us. But the problem is the gap that exists between your objectives and your current situation. Ecolab is very good at bridging this gap. So what does it look like? To bridge the gap, we focus on outcomes. Over our long and storied history, we have tremendous success with that formula. Our chemistry plus our equipment, combined with your process, will deliver these outcomes, solutions, and results. I can't emphasize this enough. We have nearly 300 account managers across the country that focus on ensuring you have the most effective chemistry, and we work closely with them on the equipment piece, making sure those two pieces of the puzzle fit perfectly together. This is unique in the marketplace, to have one supplier with the expertise and internal capability to supply these critical pieces. We work in partnership with you, ensuring our solution and your process will result in the desired outcome. So what goes into our successful outcomes? What makes a difference? Well, to start, our expertise makes a difference. We developed the first CIP solution in 1958. We developed the first electronic CIP controller in 1970. That revolutionized the F&B industry. Looking at this timeline, it becomes apparent that Ecolab was and continues to be a leader in technology and innovation. We are extremely proud of this, and it helps motivate us. We're going to spend a little time later discussing one of our latest innovations, 3D TraceR. It's a great feeling to know that after nearly 60 years after developing the first CIP, we are still the innovation leader, and nothing demonstrates this better than this technology. So what else makes a difference? Well, our process makes a difference. As I alluded a little earlier to our unique approach, we manage our entire process, start to finish, from working with you on your needs, developing a solution based on that need, to our in-house mechanical and electrical design, to our ISO-certified in-house fabrication facility, to our startup and validation teams that travel with your local team to ensure that outcome. As you probably know, there are many people that can build a piece of equipment in the garage, but only Ecolab can provide the chemistry and equipment that your desired outcome commands. Long after your outcome is validated, our local team will still be at your plant, ensuring that the equipment continues to be effective and efficient, being accountable for those results. This approach, along with our expertise guarantees that we can surround any challenge you have 360 degrees. So as I said, what makes Ecolab different? Well, we provide a solution, not just a piece of equipment. Ecolab custom designs and engineers each solution to your plant's individual challenges and requirements for each project you have. Ecolab will not try to force an off-the-shelf solution. Another difference that helps us set apart from other companies is all of our equipment is manufactured, assembled, wired, and wet tested in our manufacturing facility. That results in equipment that can be easily set in place, helping minimize installation costs and eliminating many of the surprises that can happen when starting up equipment. We offer numerous systems besides CIPs. We offer automated surface cleaning units, high pressure rinse, boosted pressure rinse. We have fixed models and portable models for when you need to remove the unit from the production floor. Ecolab offers in-house control design, and we take pride in our controls platforms we offer. We have a wide variety and size of controllers available, so we can pair the correct platform with the needs of the solution. So we don't take a one-size-fits-all approach. Our controls platforms utilize only industrial standard components. Ecolab was the first in the industry with Excel-driven workbooks that can easily be modified so you can make programming changes easily in-house or with help from your account manager without the need of a costly integrator. We will dive into detail about our bulk chemical offerings, specifically looking at bulk tanks, tank level monitoring for central ordering, and chemical distribution offerings. We'll discuss how bulk has changed over the years and what Ecolab has done to make bulk safer. Finally, we'll take a look at our antimicrobial offerings and how to improve productivity. We have tens of thousands of pieces of equipment throughout the world in operation today. We have talked about the difference makers, our expertise, our approach, and our innovation sustainable designs. How does the process begin? It begins by defining your needs based upon those four main objectives we talked about: safety, efficiency, profitability, and sustainability. If you have the CNS expertise and have defined your needs, that's great, let's get started. But most companies don't have that expertise. That's what we excel at. It begins with a call or an email to your account manager. We will start by sitting down with you and understanding your drivers, your challenges, and your needs. We can provide a gap analysis, an engineering survey, or performance audit. This is where we understand your current CNS program and we analyze it against a standard. We look at your current circuit designs and we make recommendations to those designs based upon those four key objectives. This is the start of optimizing your CNS program. That optimization looks at many ways of improving your effectiveness, efficiency, and safety. In a few minutes, you're going to hear about the impact this can have on you. You can probably describe some of your challenges as inconsistency, ineffectiveness, unreliability, labor-intensive, inflexible, capacity-constrained, and unsafe. Those are the obstacles preventing you from reaching those four objectives. Let us bridge that gap. So now let's address some solutions for optimizing your CNS process in your plant. We'll begin with CIP, Jim Chamberlain, who is one of our engineering group managers.
Thank you, Richard. As we touched on earlier, Ecolab pioneered CIP in 1958, and we've been refining and improving the CIP technology ever since. For anyone that's unfamiliar with the term, CIP stands for Clean in Place, and it's intended to clean pipes, processing equipment, tanks, tankers, and fillers internally without the need for disassembly or manual cleaning. Today, most CIP units are PLC controlled. This allows for operational flexibility and the optimization of circuits. With an Ecolab controlled CIP, we not only control the CIP unit, but we have the ability to document, graph, and remotely monitor all aspects of the CIP circuit while the circuit is running, and Josh will tell us a little more on that here in a few minutes. CIP units are designed once the circuit is started to require almost no interaction. Temperature control, automatic tank level monitoring, automatic detergent feed systems, now make CIP units much safer and require no human intervention. Every CIP we build is engineered to your specific needs, so the cleaning results are consistent and repeatable. Ecolab CIP units are engineered and built using sanitary and 3A hygienic design practices and are designed to be maintenance friendly with easy access to pumps, valves, and instrumentation. All fabrication takes place in one of our stainless steel only fabrication facilities. And all of these things add up to a consistent, repeatable cleaning and protection of your brand and reputation. Now we'd like to share a couple of case studies. And we chose the first one here because this illustrates some common challenges that many of our customers are facing today. The customer came to us with three main challenges. Their product quality was inconsistent. The plant was hampered by existing CIP capacity. Their units, their current control system was maxed out. They also had some long existing circuits that had excessive run times. Our solution was to make a site visit to the plant and perform a gap analysis. The gap analysis consisted of an engineering study from which we created existing plant drawing schematics and then generated study sheet drawings that illustrated our recommended piping and equipment changes. Once we had the plant captured, we were able to engineer and redesign the existing circuits so we could follow the production flow path, and we engineered a new dual CIP unit for that location. We also included a new controller for the new CIP unit and updated the CIP units, existing CIP units with the FlexIO control panels. The combination of circuit redesign, new equipment and control platform resulted in a flexible cleaning schedule, and the plant had room for future expansion. We completely changed the way our customer approached their cleaning and sanitation program, and our customer was able to clean parts of the plant while other areas were still in production. Cleaning results were consistent and repeatable, and we improved their product and quality brand protection. In addition to the increased brand protection, we reduced the overall CNS time by 62%, which greatly gave back production time. Our next one illustrated a challenge we had with a global partner. They came to us looking for assistance in implementing a standard Ecolab cleaning guideline for one of their Latin America facilities. Again, our members from our team traveled to the plant, performed a gap analysis and piping survey. On existing tank and line CIP circuits, we were able to show several instances where optimal flow rates and temperatures were not being met due to the existing CIP systems being undersized. Our team was able to evaluate the challenging line circuits that were made up of mixed pipe diameters. This is a very challenging scenario due to the differing line sizes. As an example, a 4-inch line at 8 feet per second requires 288 gallons a minute to clean, while a 2-inch line only requires 68 gallons a minute to clean at 8 feet per second. Our solution is a properly engineered CIP system with correctly sized pumps that were able to handle the varying flow rates and the pressures required. In our third example, we were approached by one of our partners that was capacity constrained due to long cleaning times. Our partner's existing cleaning program consisted of filling large process vats with water, manually adding chemical, and then running the agitator. This operation would take approximately 12 hours to complete. The plant asked us to assist in reducing their cleaning times and to improve the repeatability of the cleaning of the vats. Our engineering team again traveled to the plant, analyzed their current process. This allowed our team to custom design a CIP solution for them. By installing our recommended CIP, the plant was able to avoid making a large capital investment by not installing additional product vats to increase productivity. Our team solution resulted in the plant's ability to reduce the cleaning and sanitation time from 12 hours to just under 8. And that resulted in a net savings of $1 million in increased revenue for the plant. Now I'll turn it back over to Richard.
Thanks, Jim. So let's touch base again on those 4 key objectives that we talked about a little earlier. safety, efficiency, profitability, and responsibility. We looked at the first step in maximizing those objectives by understanding the need and the gaps you face, and then we talked a little bit about CIP. So, do we all realize just how much your CIP effectiveness can impact all 4 of those objectives? Every wash has a direct impact on these drivers. Josh is going to dive a little deeper into those risks and why CIP must be done well every time. Josh?
Great. Thanks, Richard. So what do we mean when we say CIP must be done well every time? And also, why is that important? So if you think of traditional validations, we pull one data point for time, temp, flow, and chemical concentration during each phase of the wash. So is that sufficient? In reality, we all know one data point does not accurately represent what is going on the wash. Let's look at chemical concentration as an example. The top chart reflects the reality today. Most customers only verify a few washes, which may give them a false comfort in that everything is okay. But if we were to measure every wash, the second chart here, they would see that some washes have overages, which is both wasteful, or in this case with a sanitizer concentration, is certainly a food safety risk. Or if there's shortages, it also presents a food safety challenge. If their situation looks like the second chart, they essentially have 2 options. They can either expand the red line so that everything falls between the relaxed standards, which in this case we know is not applicable because the EPA sets those standards, or they can take action to ensure that all their washes perform to this required standard. In order to get to the third chart, they must watch all the washes. This has essentially been impossible up until now. But before we show you the solution, we want to do a quick knowledge check. So I talked about CIP optimization or optimal CIP. So really we're talking about the 4 main requirements: time, temp, flow, and concentration, that they were at, they achieved, and they maintained within their recommended target. So what is the industry average percentage of CIP washes that are not optimal? So please submit your response now. A, 70 to 100%, B, 50 to 70%, C, 30 to 50%, or D, less than 30%. And while we wait for the results to come in, I just want a quick reminder through the chat function, make sure you're entering all your questions so we can answer them part of the Q&A that will follow our presentation today. Excuse me, within the Q&A function, not the chat function, within the Q&A. So we have a pretty astute group on the line here. The answer is 30 to 50%, and 43% of the audience today had the correct answer. With some feeling it's closer to 70 to 100%, where I think most of us, before we had the technology I'm about to share with you, we thought there was a pretty high level of confidence it was closer to that 70, 100. In actuality, it's closer to that 30 to 50%. So when you think of CIP, there's really 3 critical questions you need to ask yourself. Did you wash correctly, and did you wash optimally? So I'm going to break them down quickly. So did I wash? So think over the last 24 hours, with what confidence levels can you assume that all of your circuits and tanks that were required to wash actually washed? Essentially, someone hit start on a CIP. Then you move to, did I wash correctly? So did those critical parameters not only achieve their target, but stay within their target for the recommended amount of time? Then you move to washing optimally. So did I use the right amount of chemistry? Did I use the correct amount of energy, time, temperature, etc.? So as you move kind of left to right on the screen, your confidence level probably decreases. High level of confidence, yeah, we washed last night. Probably low level of confidence that we were optimally washing our equipment. And we know this would take millions upon millions of CIP data points that you are collecting today. We already pulled those today, yet we can't answer these fundamental questions with confidence. So that's why 3D TRASAR was developed. It essentially can do just that. It can collect, contextualize, and analyze millions of discrete and variable data points. The dashboard on the right side is just a glimpse of the power and potential of 3D TRASAR for CIP. Not only can it help drive CIP conformance, it can support all of your food safety, product quality, and sustainability initiatives. So what does this do? Well, the power of 3DT really it boils down to visibility. So now that you have all that contextualized data, that visibility will help enable you to drive consistency. So what do we mean by consistency? Take an object, take a pasteurized tank silo, for example. That silo should wash exactly the same every night. Then look at similar objects in your plant. So similar silos, maybe in a silo alley, those all theoretically should wash the same as well. So that's what 3DT will do. It'll help drive that consistency through the visibility of the data. Now that you have the visibility, you're driving that consistency, you can set optimal washes. So that becomes your baseline. That becomes your benchmark that you compare all future washes to. So any deviation against that optimal wash will be flagged as an exception. So you'll be immediately notified when any one of those key parameters has not been achieved on that wash. This then enables you to identify opportunities for improving quality, also increasing efficiency while enhancing overall product quality. The benefits for 3D TRASAR for CIP really comes in three phases. I talked a lot about this standardization. The goal initially is to drive that conformance to at least 90%. Once we have a standardized platform, then we can start shifting our focus to optimization. That's where you're going to start capturing the savings from that optimization as we continue to drive to 100%. Then long term, between the account manager and as well as the value that 3D TRASAR is bringing you, the ongoing service is going to help maintain consistency. So today we do manual verification. So just as an example of the power of 3DT versus manual verification, if an account manager spent 1 day per week in one of your facilities, spending 8 full hours verifying CIPs only, doing nothing else but verifying CIPs, it would take nearly 2 years to answer just one of the 3 basic CIP questions. Or with the power of 3D TRASAR for CIP, we can audit and validate essentially every single data point of every single wash. This is a great roll-up dashboard, whether it's presented weekly or monthly, that you and your account manager can discuss, and it will drive his or her service. It'll provide the critical information needed to make the improvements to your CIP system. It answers the first 2 fundamental questions right away. You can see that at the top. Then it tells you where most of the exceptions are happening, which area of the plant, which CIP system, which object, and what CIP recipe. And at the bottom of the chart, it tells you if the wash conformance is improving over time. This chart also holds the Ecolab accountable for making regular improvements to their CIP operations. This report gives the Ecolab account manager the critical information necessary for him or her to develop a proactive action plan for his or her next visit to the plant. So with that, I will transfer it back over to Jim.
Thank you, Josh. Now we'd like to discuss some of our facility cleaning offerings, and our next few slides are going to highlight some of those offerings. First one I want to tell you about is our ASC system. And ASC systems are designed for the automated cleaning of external surfaces and are often paired with zone manifold assemblies and varying combinations of sprays from spray balls to spray bars. ASC systems are used to clean many types of equipment. Many have moving parts such as high-speed fillers, conveyors, or equipment that needs to be run during cleaning to make sure that all the surfaces get exposed to the sanitation program. Our system is PLC controlled. PLC is used for proportional chemical feeding and accurate and repeatable results in automation of the sequencing and zone manifolds. The system is designed to handle 3 chemicals and comes with VFD and pressure sensor for total system control and design flexibility. Because the system can automatically clean dangerous and moving equipment, we can reduce or eliminate the need for manual cleaning, keeping your workers safe, freeing up those resources to be used elsewhere. Now we'd like to share a case study, and this is a great example of an ASC application. This plant is filling cans with a fast-moving wheel in tight areas, which made it very difficult and time-consuming to clean manually. Our engineers designed this ASC system and spray devices to get into all of the shadowed areas and pinch points of the filler and the protective shrouds. This filler was rinsed, washed, rinsed, and sanitized in an hour less than typical manual cleaning. That was an extra hour that we were able to get back to production every day. The next one we want to show you is our portable surface cleaning system. And this is also designed for the cleaning of external surfaces. And they're designed to have some interaction with the employees. They're not fully automated. These units are paired with sprays, spray bars, and can also be used with foam, sanitized, and rinse hoses. These systems are used to clean many of the same types of equipment as our ASC systems. A lot of the equipment we are cleaning with these units, again, has moving parts, or equipment that needs to run to make sure we get it exposed to the sanitation. This system is VFD and pressure controlled, and this allows us to deliver solution at a constant flow and pressure at the use points as water pressure in the plant varies. The benefits of this system is obviously that it's portable. There's no need for a costly distribution header, and you also pick up the ability to have manual cleaning via the hoses if needed, and it also carries the chemical required on the unit itself. And we have a case study here for the portable, where we had a customer that was having a challenge cleaning a conveyor belt on a spiral belt freezer. A couple of the challenges our customer faced may sound familiar to many on the call today. The customer was manually cleaning their conveyor belts. They also had employees transporting chemicals to the area by hand. Because the process was so manual, they had inconsistent cleaning results and they had inconsistent chemical usage. In addition to those challenges, the customer also had a few other obstacles to overcome. Even after their current process of CNS, they had leftover soil on the belt and they had count issues. The customer also had budget issues that wasn't going to allow for a costly header installation. So after listening to our customer's challenges, working with that customer, our Ecolab account manager, we came up with a solution, and that was the portable unit that was less expensive and only required installation of spray devices on the belts that were being cleaned. This unit utilizes a VFD-controlled pump and features aspirated detergent feed system for accurate and consistent concentrations. Since the unit was portable, it didn't require the installation. Detergent was safely transported on the unit to and from the location. Our solution resulted in a sanitation that is now repeatable time after time. Overall, sanitation efficiency was improved, freed up personnel to work in other areas of the plant while the spiral belt freezer was being cleaned. This facility is now a benchmark within their organization for their sanitation program, and other locations within that organization are asking for the same solution for them. And with that, I'll turn it over to Andy. He'll tell you about some of our other offerings.
Thanks, Jim. Our next piece of equipment we would like to talk to you about is our central dosing system. A central dosing system is designed to supply detergent or sanitizer throughout the plant to multiple use points. Some of the more common use point locations are drop stations, doorway foamers, spray bars, and other non-recirculating points in your facility. Our central dosing system offers advantages over traditional systems. Our Ecolab dosing system is a skid-mounted tank and pump-based unit that is engineered and sized to meet your plant's requirements, whether that's low water pressure or a large number of drop stations. One of the things that makes our dosing system stand out is that we use a flow meter to meter the incoming water and proportionally feed detergent or sanitizer into the tank. Paired with our proof of delivery sensor, we ensure that the detergent and sanitizer is being delivered when the system is running, and will put the system into a standby mode if needed due to a chemical barrel or day tank becoming empty. Our tank-based system allows us to have a buffer of volume of solution, so if fluctuations occur in the incoming water volume or the pressure affects the concentration. Take a look here at a case study. In this case study, our partner had a safety issue. Their employees were transporting detergent and sanitizer throughout the plant, and their cleaning and sanitation program was becoming very labor intensive. This cut into production due to the long sanitation time. Our solution was to provide a central dosing solution for their foam and sanitizer needs. After completion of a site survey, we were able to determine the required performance criteria and supplied them with 3 separate dosing systems. One for their central foam, one for their central sanitizer, and one for the doorway foamers. Because the detergent and sanitizer were now automatically proportionally dosed directly into the tanks, we eliminated the need for handling detergent and sanitizer and creating a much safer process. Detergent and sanitizer usage went down as a result of our proportional dosing. We're now going to look at a water reuse system most likely found in our protein markets. The Ecolab water reuse system is a point-of-use reuse system, meaning that instead of taking water from one part of the plant, like a bird washer or chiller, and reusing it somewhere upstream in the process, our system collects water from the point of use and reuses it right back into that same point of application. This simplifies the piping and installation and allows us to guarantee a minimum of 75% water savings for the bird washer water reuse system. Each system can supply up to 200 gallons per minute of water reuse at 100 psi. It also meets the USDA criteria for online reprocessing, meaning that it can replace the existing OLR intervention or generate a labor savings for those facilities that may not currently have an OLR intervention. The chiller WRS concept is similar to that of the bird washer WRS, except that the primary water savings comes from the ability to hold the chiller water for up to 5 days without dumping the chillers. It is also possible to reduce the amount of chiller makeup water being added to the chillers. Because the chiller water is cooled to just above freezing, the chiller WRS can also generate a significant energy savings because the plant does not nearly have to cool as much water. The bird washer WRS and chiller WRS are PLC controlled and include monitoring and alarming for key system parameters. They also include an integrated CIP sequence which simplifies and automates the cleaning of the system at the end of production. As we know, this can be one of the most difficult obstacles to overcome with competitive systems. So in this case study, a poultry producer wanted to reduce their water use from 6.5 gallons of water per bird down to 4 gallons. Needing to increase the production, but their water treatment plant was already at its capacity. Their spend on online reprocessing chemical intervention was also becoming very significant. The plant's main sources of water use were 4 bird washers. We installed our Inspex bird washer water reuse system on 2 evisceration lines. Our process was validated by the USDA water reuse criteria and helped develop protocols for online reprocessing approval. These 2 systems saved over 68 million gallons of water annually, which came out to about $190,000 per year. Because of our WRS system, we were able to increase the production line speed by 20%. This allowed the plant to avoid a $500,000 installation of separate OLR treatment and expansion of their water treatment facility. At Ecolab, we strive to ensure safe and timely bulk deliveries each and every time. We offer an industry-leading 6-year warranty on all tanks that use Ecolab chemicals, and these tanks come in a wide variety of sizes. We are able to design distribution systems and safely move chemicals from the bulk tank to day tanks throughout the plant. We're going to take a look at some of the differences in materials in the tank construction in a short video. The first video here is our cross-linked polyethylene. It's Ecolab's recommended tank material. So this tank is filled with water, and as it drops, you can see that the tank does not split open. We're going to put side by side with fiberglass reinforced polyethylene and linear polyethylene and see how those tanks hold up compared to the cross-linked polyethylene. As you can see, it's no match. The other ones shatter immediately on impact. In this case study, we had a partner that came to us to help eliminate the time being spent moving chemical barrels throughout their large facility. Based upon the plant's chemical usages, we were able to provide 2,500-gallon bulk tanks for their cleaning and sanitizing chemicals. We then designed a distribution system to safely move these chemicals to 5 different locations in their facility. We were able to install our tank level monitoring system that was able to remotely track their chemical usage. By installing and utilizing the tank level monitoring system, our distribution facility is able to track the chemical usage and automatically schedule optimal deliveries. Now let's get back to Josh.
Great. Time for a final knowledge check, then we'll answer some Q&A coming in. So just a reminder to continue to submit your Q&A questions for us, and we will answer those shortly. So question, Ecolab account managers provide training and report observations on A, bulk offloading safety, B, chemical safety, C, product application, or D, all of the above. So you can submit your answers now. Give that just a moment for the results to compile. All right, and the answer is A, all of the above. Excuse me, B, all of the above. So we've covered a lot of solutions to help impact these 4 objectives today. Now we'd like to hear what questions you may have to help optimize your CNS program. All right, and questions are coming in, so continue to submit those. The first question, I guess a lot of questions are around how do I improve capacity and reliability? We'll open that up to anyone on the team.
Okay, so we talked about the kind of the first step is that gap analysis, the engineering survey, circuit analysis, right? That's really step 1 to defining what your needs are and bridging that gap that we talked about between the objectives that you have, those 4 main objectives, and your challenge, right? So step 1, call your account manager, engage him or her, and they will start the process.
Great, and I think that answers a couple other questions. This one is, although it's specific to Canada, getting initial support on projects. This one is poultry and WRS, but I think for all engineering projects, it would be working with your account rep?
That's correct.
Great. Question came in on plant has a MicroMaster 300. What are the benefits of upgrading my central dosing system?
One of the benefits for that upgrade, the central dosing system that Ecolab engineers, it allows for that bigger tank. So with the proof of delivery to ensure that the chemical barrel's never going empty and knowing that that chemical is going in every single time. The tank also allows us to create a larger buffer if we have issues with low water pressure, as well as a more thorough mixing of the solution.
Great. A follow-up to that, is the central dosing system capable for several drops to supply entire facility, or more than one unit will be needed?
Yeah, it can supply numerous drops, and that when we're engineering the system, we need to know those number of drop stations that would be used at any one point, so we can size the tank and the supply pump accordingly.
Thank you. Question on 3D TRASAR. So which Ecolab systems is a 3D TRASAR system compatible with? It's like this individual, I'm using a 5500W system. So I guess it really boils down to, will 3D TRASAR work with that hardware or any hardware in general? I'll turn that to Jim.
So we can put 3D TRASAR on any of our PLC controlled systems. Some will require additional hardware or additional programming. But that can be done specifically on the 5500W.
Great. Yeah, for the most part, it is controller and PLC agnostic. I think what you're really looking for is just a network connected plant. Okay, questions are still coming in. The question, maybe open-ended answer, how long does it take to have the 3DT process optimized in a plant? That really depends, right, where you're starting from. So if you remember the slide, we started with standardize, and that's really on conformance, and then we move into optimization. So standardize, depending on where you're starting, if you're at the lower end of conformance, down at 30%, it will take time because you want to methodically go through the plant, focused on those that are the most out of line. And again, based on the complexity of your plant, that can take anywhere from, a month to a handful of months, maybe even upwards of a year to really dial in the system. Then once you get standardized across like objects, that's when you start going in and optimizing the plant. And that'll also depend on what you're really focused on. If you're looking at reducing just time, if you're looking at reducing temperature, if you're looking at reducing chemical concentration, it really will vary. So that'll be something that you'd have to work with your account manager, and they can help prioritize that. All right. Question on deliverables of a gap analysis survey. I think Jim talked about the gap analysis.
Yeah, so typical deliverables, every gap analysis is going to be a little different based on the customer's needs. But a typical deliverable would be a set of existing drawings of the current process, followed up with a study sheet, which is a drawing that shows our proposed piping and equipment changes. And many times that comes with a report from the trip for our observations from our engineers. And then that's usually followed up with a quote for the changes that we're showing on the schematic flow diagrams.
Great. Question around how do you validate CIP systems? So that probably is a webinar in itself, and one that we actually covered off previously. So specifically around CIP validation. And at the end of this, I'll provide more detail. We will be providing links not only to this webinar, but past webinars. And I would encourage you to go out and look at one that is detailed around CIP validation. If you have any other questions after reviewing that, again, your account manager, account rep would be able to work with the broader team in the room here to help support you. question around 3D TRASAR, are additional sensors required? 3D TRASAR's additional sensors required for 3DT. Short answer is no. Short answer is no. There are some basic requirements there to have your flow, time, temp, and a conductivity meter. And based on that information, we can get you 90–95% of the information that you need. We can do a CIP assessment. If there's any deficiencies there, we can work with you to integrate any sensors, but 90–95% of the CIP skids out there today would be applicable and provide value right out of the gate. A question around guarantees. So do you offer guarantees you can improve my cleaning time?
So as we talked about that gap analysis site survey, right, that we're going to, at the end, and Jim talked about the deliverables, one of the deliverables is defining what those gaps are, right? And typically, we submit a proposal on what we recommend a solution would be. But along with that proposal, we typically outline in detail a circuit analysis. We look at ways that we can improve that efficiency. And, you know, we have some preliminary studies that you follow these recommendations, you're going to reduce your cleaning time by, you know, a certain percentage, whatever we estimate after that circuit analysis. So, you know, before you purchase any equipment, you're going to have a pretty good feeling of what impact you're going to see.
Great. And then there were some pretty specific, or a couple very specific questions on 3DT and applicability for your plant. Without kind of having a dialogue there, I think it's a little bit challenging to answer some of those questions. So what I would do is reach out to your account manager. He or she can get in contact with our 3D TRASAR expert, and we can do an assessment of your plant and work with you directly to answer any of those questions. So with that, that wraps up the Q&A portion. So I appreciate you guys sending in questions. So we covered a lot of material today and had some really great questions for our experts, so we appreciate that. But before we go, early next week, anyone who registered for this event will receive a follow-up email with a link to the on-demand webinar recording and a link to the resources that are available for you to download and share with your colleagues. So you can see it will provide an engineering solution and capability overview, some information on 3D TRASAR CIP, some great testimonials from some customers that have been on 3D TRASAR, and as well as a case study that has been widely circulated from Kemp's, one of our customers, early adopters of 3D TRASAR for CIP. So with that, thank you for attending today and your continued partnership. Please contact your local Ecolab representative if you have any questions about optimizing your cleaning and sanitizing programs. Thank you.